Okay, so today, this is what we're going to be doing. So we've been working on solving quadratic equations. So the first thing we're going to do is discuss the quadratic formula and the discriminant. And hopefully you watched the video. And then we're going to do a real short Kahoot just over just some of the basics. And then we'll go through and solve the book problems using the quadratic formula. It's pretty much just plug and chug. If you can plug in into the quadratic formula, then you can solve the problem. Some reminders, our next test is the 6th. I mean, test 6 is Wednesday, November the 11th. Oops, I think I forgot to do the reminders. Here's the reminders. Our next test is Wednesday, November 11th during class. Like I said, I haven't graded test 5 yet, but after test 5, if you're not passing, we will be contacting you within the next week or so to discuss the options you may have. You can pass the intermediate portion of the class, MATD 0414, even if you don't pass the 1314. Hopefully you'll pass both parts, but there is a possibility that you may just want to concentrate on passing the one part. Also, remember, guys, especially as we get closer and closer to the end, attendance, class participation is definitely expected. If you miss 10 class days and have a grade average below 60, we can withdraw you from the course. We don't promise to do so, and we don't really want to do that, but it is our option to do that. So make sure you know that. So today we're going to be using the quadratic formula to solve quadratic equations. Up till now, we've been solving by using factoring and also taking the square root of both sides. And there's also the other method that Matt showed you, but we didn't really use, was completing the square. You can also use a calculator to solve quadratics. The thing about all of these methods is that they can't be used all the time, because sometimes you need a perfectly exact answer. And when that is the case, and not all quadratics are factorable at all, completing the square will give you an exact answer. But basically what the quadratic formula does is take completing the square and just take all the steps that you would do in completing the square and put it into one formula. So this is the formula you have to memorize. Probably everyone in the world knows this formula at some point, and like, I bet if you asked your parents, they might remember it as well. Okay, so I wanted to, not do present mode. Here's a quick little, I usually sing this to my class, but it's really awkward, especially over the internet, to do this. People, I know I embarrass people. I know they're sitting there being so embarrassed for me. So I'm going to just play it for you.
It's got no sound.
Can you hear it?
No, you have to share. It's a little option when you share your screen. You have to share the sound with it.
Oh.
So if you stop share and then you go back and share it.
Let's see if I can figure this out.
I think you have to stop the share first.
Okay. I'm going to stop this, because it really doesn't do any good if you can't hear the sound. Hold on just a second. Let me see if I can figure this out. So new share. Share. Is it advanced? Maybe.
It might be.
Music. I hear it. Yeah. Okay. Here we go. Let's try this again. Can you not hear it now?
We can hear it, but not see it. It's okay.
Is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
X equals
X is equal to
plus
negative
or
b
minus
plus or minus the square
squared
root of
minus
b squared
4ac
minus 4ac
over
all
2a.
over 2a.
You want me to chime in with the bums?
Plus or minus the
Plus or
square
minus
root
the
of b
square
squared
root of b
minus
squared minus
4ac
4ac
all
all
over
over
2a.
2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, and there's a ton more little cute stuff on the internet that you can look up. If you look up quadratic formula song, there's all kinds of funny things that students have put together. All right, so I always like to derive the quadratic formula to show you why it works. And we have the standard form of the quadratic and we have the vertex form of the quadratic. And if we take this standard form and we complete the square, we can get it into vertex form. It looks like this. And now all we have to do is set this vertex form equal to 0 and solve for x. And voila, we get the quadratic formula. So basically all we're doing when we're using the quadratic formula is we're completing the square and then we're taking the square root of both sides, and it's all just packed into one beautiful formula. So and you can use it no matter what. Even if you're horrible at factoring, you can always just use the quadratic formula. So the other thing that's in this lesson is the discriminant. And the discriminant, if you have a quadratic equation in the form ax squared plus bx plus c is equal to 0, the discriminant is just the part that's under the radical, the b squared minus 4ac. And it tells you a whole lot about the equation before you even try to solve it. So sometimes that's really helpful, especially if you're working with an application type of problem and you don't want to go through the whole formula. If you just look at that b squared minus 4ac part, if that part that's under the radical turns out to be a positive number, that means that you're going to have two real solutions, which means that the graph will cross the x-axis twice. Of course, it can't ever be more than twice. If the discriminant is exactly equal to 0, that means you're going to have one real solution.
Miss Watson, are you trying to screen share something?
Yeah, is it not staring?
No.
Oh gosh, you guys.
It's just sharing your sound. That's all it's doing right now. That's what it looks like.
Okay, I'm going to stop sharing again and try this again. Okay. Sorry. Screen share. Basic. Okay, here we go. Okay, so what I was trying to show y'all was start that deriving the quadratic formula is if you take your standard form and you use the steps for completing the square, you can get it into vertex form. And then if you take that vertex form and set it equal to 0, and then using the square root property, you get the quadratic formula. That was what I was trying to say earlier. Then I'm talking about the discriminant. The discriminant is the b squared minus 4ac portion of the quadratic formula. And it can tell you a whole lot about the formula and what's going to happen before you even try to actually solve it, which is especially nice to know if you're working with an application. So if the discriminant is positive, b squared minus 4ac is bigger than 0, that means you're going to have two real roots, which means that the parabola will cross the axis twice, cross the x-axis twice. If it's exactly equal to 0, that means you're going to have one real solution. This is called a double root. We'll get into that, I believe, tomorrow or later on in this section. And that just means that the vertex is going to lie on the x-axis. It only touches the x-axis one time, tangent to the x-axis. And finally, if b squared minus 4ac is less than 0, that means you're going to have a negative value, which under the radical is would be imaginary solutions, or there would be no real solutions. And that means that your parabola won't cross the axis at all. Okay, so now let's do a really short Kahoot, and then we'll look at the problems. Again, if you participate in the Kahoot, I certainly hope you will. If you're able to, I will give you extra credit on this homework assignment. No Halloween music. Okay, I'm fixing to start. So if you want to jump on at any time, feel free to do that. Make sure you write down the game pin. And if you can't get on the Kahoot, please follow along. First thing you should always do when you are solving a quadratic is set it equal to 0 in order of exponent and identify your A, B, and your C. That will cause you not to have a lot of grief if you will take the time to do that. Okay, so this one, most of y'all got good. And if you didn't, you've made a very common mistake. If you set this equation equal to 0, this becomes x squared minus 4x minus 1. You have to do that first before you can identify. Oh, I thought most of y'all got it. Actually, no. So let me pull this up real quick. Just want to make sure you
Yeah, I actually got A equals -1. So maybe I'm wrong. I don't know.
Okay, so let's look at this.
It's not even an option.
Yeah, you can flip them all by a negative, and it should work as well.
Oh.
It just depends what side you move things to.
Uh-huh.
Yeah.
Okay, so what we had was x squared minus 4x plus 1. X squared equals 4x plus 1. And if you set this whole thing equal to 0 by subtracting 4x, that's going to be x squared minus 4x minus 1 equals to 0. You have to do that first. And like Michael said, you could also do it to the other side and say 0 equals negative x squared plus 4x plus 1, and that would work as well. So in this case, A would be 1, B would be negative 4, C would be negative 1. So you have to set the whole thing equal to 0 before you identify your A, B, and your C. And if you did it this way, A would be negative 1, B would be 4, and C would be 1. And that would also work. Hey, Hunter. Which part of the quadratic formula is the discriminant? Okay, the discriminant is just the part that's under the radical. It doesn't include the radical or any other part of the quadratic formula. It's just the b squared minus 4ac part, just that part, because that's what's going to tell you the information you need to know regarding what type of roots you're going to have. So a lot of people, before they ever even start the problem, before they ever start to even solve the problem, will find the b squared minus 4ac part of the equation. Okay, this one, there's more than one right answer. Pick all that are right. If b squared minus 4ac is negative 7, what is true about the quadratic? Okay, if b squared minus 4ac is negative 7, we know the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And yes, you do need to memorize that. So that means that we're going to have, we don't know what the rest of the stuff is, plus or minus the square root of negative 7 over 2a. We know that anytime we have the square root of a negative, that's going to be imaginary. So these are going to be two imaginary roots. And if they're imaginary, they can't be real. Those are two totally distinct. You're either real or you're imaginary or complex. So there are no real roots, which means there have to be two imaginary roots. So these two things always go together. If there are no real roots, there will be two imaginary roots. If there are two imaginary roots, there will be two real roots. I mean, no real roots. If b squared minus 4ac equals 0, what's true? Okay, so there are 3 correct answers. So if x equals -7 plus or minus, if the discriminant is 0, that means this would just be -7 over 15. So x would just equal -7 over 15. And then your parabola would either go up or down. So it could either look like that, or it could look like that. Either way, you can see that there is exactly 1 root, and it is the vertex of the parabola, and the parabola only touches the x-axis 1 time. If the discriminant of a quadratic equation is 1, which of these might be its graph? Okay. All right, so if it's the square root of 1, that's a positive value. So this would be -b plus or minus 1 over 2a. And you could split that up into -b plus 1 over 2a and also -b minus 1 over 2a. So that means that there's 2 roots, which means it's going to cross the x-axis 2 times. So if the discriminant is a positive number of any kind, that means that the graph is going to cross the axis 2 times because there'll be 2 roots, 2 solutions. F of x equals to this lovely equation models the world population in billions from 1950 to 2020 in the year X. According to this model, when did the world population reach 7 billion? Which one of these would help you find that? Good, it's 5 and 4, that's correct. So let's look at this. So this, it says that f of x models the world population in billions. So f of x is the world population in billions. So if we set the equation equal to 7, that's what we're wanting. Now, if they asked us what would be the population in the year 1955, that's when you would plug 1955 into each one of these x's. And sometimes you have to be careful with these type of problems because they'll say where like 1950 would be the year 0. So you have to really be careful about how the problem is stated. Then if you take this equation, the 0.000478 x squared minus 1.13x plus 172.0.1 equals 7, and subtract the 7 from both sides, you're going to get that a is 0.00. Oops, I left off a 0, sorry. So actually that one, I meant that one to be right, but, and then B would be 1.813, and then C would be whatever the 1720.1 minus 7 is, just the 1713.1. Okay, so to go over just really quickly what we've been talking about here, if you have when we're talking about a discriminant, the discriminant is just the b squared minus 4ac. And if the ba squared minus 4ac is positive, that means you're going to have 2 real roots, which is the same thing as 2 real solutions, which is the same thing as 2 real zeros, which is the same thing as 2 x-intercepts.
So they don't actually talk about the real zeros of the x-intercepts till the next Roxwell 3.2 section.
Okay,
But
so you'll be seeing all those
yeah,
words.
they'll see it and
so,
they'll see it again then.
Yeah. So that what that means is if you graph the equation, it'll cross it 2 times across the x-axis. If b squared minus 4ac is 0, that means you have 1 real root, or 1 of all of those. And what that means is that the vertex is going to be on the x-axis. And if b squared minus 4ac is negative, that means there's going to be no real roots or real solutions. So that means that there will be 2 imaginary. And what that means is the graph will never cross the axis. Okay. All right, so now I want to look at, again, this is just plug and chug kind of stuff. Oops, let's look at the top people so I can. Yay, Elliot. Yay, Aurora. And Well, come on. My internet has been flickering in and out. I don't know why. Hunter, yay, Hunter. Okay. If you haven't watched the video, I would recommend that you do that. Okay, so we are going to now be working on these problems. And basically, if you look at these, it is just identifying A, B, and C and plugging into the formula. And then on 147, it talks about the discriminant. So let's talk about let's do the first one together. And then I'm gonna let you work on these because basically, again, it is just totally plug and chug. So in this first problem on 113, A is 4, B is 1, and C is -3. And I think it's very interesting how they put all the book problems, they're already put in the right order. That's not the case on the written work on that. So make sure that you put them in the right order first. As a matter of fact, I think on the written work, there's one that's like this, x minus 5 times x plus 2 equals 7. And so what you're going to have to do there is actually multiply these out and then subtract the 7. So you'd have to do x squared plus 2x minus 5x minus 10 equals 7. And so then this would be x squared plus -3x or minus 3x minus 17 equals 0. And then you would use the quadratic formula. So there will be one like this on the homework where you have to actually do that before you can. Otherwise, it's a pretty short assignment, but there is one like that on there. Okay, so on this one, we've identified our A, B, and C. So I'm going to say x equals opposite B plus or minus the square root of B squared minus 4AC, all of that over 2A. And this would be -B plus or minus the square, oops, sorry. This would be, my brain sometimes, -B plus or minus the square root of B squared minus 4AC, all of that over 2A. So A is 4, so everywhere I have an A, I'm going to put in a 4. B is 1, so everywhere I have a B, I'm going to stick in a 1. And C is -3. And then we just simplify that. So that's going to be -1 plus or minus the square root of 1. And -4 times 4 is -16 times 3 is 48. Over 8. So that's going to be -1 plus or minus the square root of 49 over 8. And that would be -1 plus or minus 7 over 8. Okay, so now I'm going to split this up because I have two. I know I have two answers. It's going to be -1 plus 7 over 8 or -1 minus 7 over 8. So this would be 6 over 8, which is 3 over 4. And this would be -8 over 8, which is just 1. So this one, because I'm getting two rational answers, rational means, of course, that they can be written as fractions. They're not like a pi or some number that repeats indefinitely or repeats in an doesn't repeat at all, sorry. We could have actually solved this problem by factoring, but probably it's easier to do it by quadratic formula. Okay, so as you go through these, make sure you identify your A, B, and C, and then plug into the quadratic formula. Then let's see, the next set of exercises. Was there a different set of directions maybe? Okay, I'm going to make it a different set of directions if there wasn't. I want you to give me on 129, 131, and 141, I want you to give me approximate answers. Okay, so let's look at what I mean by that is, so here I have A is 2, B is 3, and C is 3. Now you can only do that if it's not imaginary. So hopefully this one doesn't come out to be imaginary, but if it does, that's okay. So X equals opposite B plus or minus the square root of B squared minus 4AC. And this one is going to come out to be imaginary. So all of that over to A. And I could tell this is going to be imaginary because I know that 9 minus 24 is a negative number. But let's go ahead and finish this one out. So this would be -3 plus or minus the square root of 9 minus 16, nope, 24 over 2A. And that's going to be -3 plus or minus the square root of -15 over 4, which would be -3 plus or minus, you'd have to pull out your I. All of these might be imaginary, I'm not sure. So let's see, this one, this would be 36 minus 4. Yeah, this is going to be imaginary. 24 squared, let's see. 24 squared. This one will not be imaginary. So this one you could actually approximate. So when I say approximate to the nearest value, that means use your calculator, is what it means. Use your calculator to find out what the answers are going to be, because they won't be rational, more than likely. And then these are totally the discriminant. And remember that if B squared minus 4AC is larger than 0, there's going to be 2 real roots. If B squared minus 4AC is equal to 0, there's going to be there's going to be 1 real root. And if B squared minus 4AC is negative, there's going to be no real roots, which means there will be 2 imaginary. Okay, so I'm going to go ahead and put y'all in groups. And and let y'all work on these for about 20 minutes or so, and then we'll come back and make sure you're doing them correctly.
probably missed it already, but did you specify which ones we're gonna work on? Or do you just go from top to bottom?
I think she was talking about 147. Did y'all do these already?
No, I haven't yet.
Or did y'all do these?
I was working my way through 123 because we kind of skipped ahead to 120.
Mm-hmm.
This is the easiest way to do it. I'm here trying to figure it out. Okay. This might work. So what's going first?
Oh, hold on a sec. Still writing this out. Okay. All right, yeah. Right, so that would be -6 plus or minus. Wait, which one are we doing?
Yeah, it would be a -6, right?
Right. So we're doing 123 right now, right?
Yep.
Okay, good. Yeah, so -6 plus or minus -6 squared. -4 times 2 times 3 over 2 times 2. All right. Afterwards, when we did the square root, you should. I came out to 132 for inside the radical.
It should be 36 minus 4 times 2 times 3. 36 minus 24. What'd you get for the radical?
I got like 132.
Mm,
All right, I'll go back and double check.
This is minus. This is positive. This is positive. So 6. I got plus or minus.
You know what it was? My 36 was negative. So because positive, negative to the negative was a positive. So bam, go back and do that one. Interesting. I got 291 now.
What is minus 6 squared?
36.
Yeah. So this is 36. And this is 4 times 2 is 8 times 3 is what? 24?
Right.
So what's the sign between these things? What's the operation?
It should be subtraction.
You should be subtracting these things. Your 36 is going to become positive when you square that negative. This thing overall, I have one negative sign, so it should be.
It gives us 6 plus or minus the square root of 12 over 4.
Mhm.
And that goes to 6 plus or minus 2 radical 3 over 4.
So you can simplify radical 12 as what? Root 4 and root 3?
4 and root 3. Okay, yeah.
Which would give you a 2 on the outside, right? You said it right.
That would make the solutions 6 plus 2 root 3 over 4 and 6 minus 2 root 3 over 4.
Yeah, I would simplify this somehow. There's a few ways to simplify it.
Sorry, would it be 3 halves plus 2 radical 3 over 4?
Yeah, so separate each of these over 4, right? So if you do 6 over 4, equal sign here. Plus or minus, is it still a sign in between? And we do 2 root 3 over 4. And then we should be able to simplify. You said this was 3 halves. But you should be able to simplify that other thing a little bit too. I don't know if you said it or not.
I don't think I did. That simplified the 2 to a 1 and the 4 to a 2?
Yeah, that's what you can do.
Okay, cool.
2, 1. I think alternatively, you can divide everything here by 2. You'll get the same thing. But you have to divide things outside the root with things outside the root. Did you get that, Timothy?
Yeah, still following along. Sorry about that.
Elliot, you doing all right?
His mic might be down.
Okay.
125. Why not? X squared plus 8x minus 40.
All right, you got it written down. I think I'm gonna go to that other group and make sure they got something going
All
on.
right.
All right, I'll bop on over if I get enough time.
Appreciate it. Thank
All
you,
right, see
Real.
ya.
Later.
Got room number 3. I'm gonna lose my screen. Here's the screen. So what are y'all working on?
I kind of skipped around because I got stuck on 123. I didn't know how to like continue to simplify. I got stuck at 6 plus or minus 2 radical 3 over 4.
So it sounds like you got it all set up. X equals negative b 6 plus or minus. And what did you get stuck on? You said it's 6 plus or minus what?
It was by the time I did all the work, it was 2 radical 3.
Okay, yeah, because you should get 12 in here is what
Yeah.
I just figured out from the previous one. And it was over 2 times 2, which should give you 4.
Mhm.
So this sounds correct. And then you do this is 2 radical 3. So 6 plus or minus 2 radical 3 over what, 4?
Mhm.
So you want to simplify this. So there's at least 2 ways to simplify this. But the easy sort of way is to put these both over that same fraction. So if I see the 6, I can put the 6. Ooh, it's whistling. Got the wind whistling through the door.
It would just be the 2 radical 3, or would it just be the 2 because?
So this is plus or minus 2 radical 3, and we want to put both of these over that denominator.
Mhm.
So 6 over 4 we can simplify.
Yeah.
We can reduce that fraction to
3 over 2.
yeah, it's 3/2. And this is plus or minus still. And we can simplify this thing a little bit. So this is that part where like things inside the square root get simplified with things inside the square root, things outside with things outside. Don't want to mix those things. But if I'm looking at this, I have what, 2 over 4? How do I simplify 2 over 4?
Divide by 2. So
Divide by 2. So this is
1/2.
1, 1 and 2. Yeah. So this is what, root 3 over, ooh, excuse me. So this should be what, root 3 over 2 now.
okay, yeah, I was trying to figure out how to simplify it further, but
Yeah, you got most of the way. That's most of the problem.
and then now we got down to I just finished 131. I hope.
Do my mouse select? No mouse. Okay. 131. So what's happening on this one?
Well, it looks like it's gonna be imaginary numbers, but I just plugged them in. I got 6 plus or minus -6 squared minus 4 times 8 times 2.
Minus 4 times 8 times 2. Yeah, that's it.
And then over 2 times
This is taking me too long.
8.
Times 2.
When I simplified it down, I got 6 plus or minus -28 over 16.
This is 36. The 8 and 2 are positive. So 36 minus what? 4 times 8 times 2. So in the square root, you got a minus 28. Is that what you're saying?
Yeah. And then I just pulled out the I, and then I actually don't think I did finish it all the way through.
Get out of here. So if you pull out the I, you can pull out what? 2 and an I think. 2I root 7. Is
Yeah,
that how you
yeah,
simplified it?
Yeah, that actually I hadn't simplified all the way down the answer yet, but
Okay. So 8 and
That does
that
make
will give me what? 16.
yeah.
So what'd you do? You didn't pull out the 2. Is that what you did?
Yeah, I just
All right.
that's
Pull out the I.
so is
I
that
think
the final answer? Or
There's that
could
thing
you
we can simplify this a little bit.
Yeah.
So the first thing is what? 6 over
X equals 6 over 16.
16 plus or minus. And then that thing over 16, 2I root 7.
Mhm.
So this we can divide by what? 2 and get 3/8. Is that what we can do? I think 3/8 is
Yeah.
simplified.
I think that's it.
3/8. Horribly drawn, but it's down there. Plus or minus. This we can simplify out what? Divide this by 2, divide this by 2.
Yeah.
And so this is over 8. So root 7, I root 7 over 8. And I think we're about to be leaving the breakout rooms pretty soon. The other way you can simplify this is you have 3 different terms here. You just have to make sure things outside the root get divided by things outside the root. So we're dividing those 3 things by 2. You could get the same solution, 3 plus that over 8. That'll give you 1. We're dividing everything by 2. You just have to make sure to divide all your terms by 2. And so if you separate them, I think it makes it a little easier to make sure you catch all your terms and do all your terms separately.
Yeah, I
Sometimes-
think I just forgot about it for a second.
Sometimes
I was
people
like,
try
what am
to
I
do
supposed
just like the 6 and the 16 and they'll forget about this 2 over here, right?
Yeah.
You have to do all the terms on top. Get the division. Seems like they're working through them.
Yeah. Okay, so oops, sorry. The group I was working with, we got through the majority of them. So I just want to make sure that y'all agree with these answers, and then the ones that we didn't do, I'm hoping that another group can tell us what the answers to those are. So we did 113 together as a class. So then on 125, my group got -4 plus or minus 2 times the square root of 5. Does everyone agree with that answer?
That's what my group ended
Oh,
up with
good.
as
Thanks,
well.
Hunter. What about the other group?
That's what our group got too.
Okay, thank you, Olivia.
Mhm.
Okay, and then on 129, we got, 123, which I skipped, we got -1 plus or minus 7. No, I'm mixing up mine. We got 3 plus or minus 3 root 2. Is that what y'all got? For number 123?
Yeah, I think we split them like 3/2 plus or minus radical 2
Yeah.
over 2.
Okay, yeah, okay, so that's good too, or 3
Because
halves.
I kind of gear them that direction to split.
I like that too. I do like that because it makes it where you're not going to forget something.
Yeah.
So either one is fine, but this is probably a little bit better if you split it up because that ensures you get everything simplified correctly. Okay, and then we did 129 together. And my group did not get to 131. So the group, did any group finish that one?
No, we didn't get there.
So let's go through these just quickly. So on
Someone-
131,
I think group 3
always
did that one,
identify
didn't y'all?
your A. Did another group get it?
I thought group
Olivia,
3
did-
did it, but maybe I'm wrong. Maybe it was a different
Okay,
one.
Olivia, did y'all get it?
Oh, yeah, I think we did.
What do you get?
Do you want me to work it through, or do you want me to
Yeah,
just say?
please. That would be great.
Well, we pulled out the A, B, and C. So for A, we got 8,
Okay,
and B was -6.
Okay.
C was 2. And then
perfect.
when we plugged it in, it was x equals 6 plus or minus square root of -6 squared minus 4 times 8 times 2
Good.
over 2 times 8.
Okay,
And then when we simplified it, we worked it down to x equals 6 plus or minus 36 minus 64 over 16.
Mhm.
Then x equals 6 plus or minus -28 over 16. And then we pulled out 2i. That looked like all we could really do.
okay, so
So 6 plus or minus 2i, 7 over
okay.
16.
Uh-huh.
And then we separated them. So we did x equals 6 over 16 plus or minus 2i radical 7 over 16.
Okay,
And then we ended up with x equals 3/8 plus or minus I radical 7 over 8.
beautiful. Okay, and I like separating it. What I showed my group, and just, it's fine if you do this. What I do a lot of times is I just highlight all the non-radical pieces and ask myself if there's a number that goes into all 3 of those pieces, and you'll get the same thing, only it will be as one fraction. But I actually like this better. I think it's probably less likely to make mistakes if you do that. Okay, what about 141? Did any of the groups do 141? I just want to talk about 141 just for fun. If you look at 141, you see that the first term is a perfect square and the last term is also a perfect square. So probably this one would be easier just to factor because it looks to me like it's a perfect square trinomial. But we're not doing that in this section. We're doing quadratic formula. But if you did factor this, knowing that it's a perfect square trinomial, this would be 4c plus 9. And would that even work? No, it's not. So it's not a perfect square trinomial because 9 times 4 is 36 times 2 is not 24. So even though it looks like it is, it's not. So forget that. Okay, so we would just go through it the same way. Hunter, will you walk us through this one?
Yeah, let me get a sheet of paper. I'm still
Okay.
writing out the stuff for 131, but I can go
Okay.
back.
I'm
All right,
hoping, you guys, that this doesn't look too intimidating because again, it is just plugging in numbers and being careful with your signs, and pretty much that's it. So,
All right, you said 141?
yes.
It will be. Sorry, my printer stopped working, so I have to write all this out by hand. So give me
That's
just
fine.
a moment.
So
I think that is a perfect square.
is it?
I think so.
Let's see, 4c and oh, it is. It is okay. Yeah, I thought it was, and then I looked at it again. And I thought it wasn't. So if it's a perfect trinomial, the square root of 16c squared is 4c. The square root of 9 is 3. And 4 times 3 is 12, times 2 is 24. So this would be a perfect square trinomial. And then you would just say 4c plus 3 equals 0. And then solve for c, and you would get c is equal to -3/4. So that would actually be a lot easier if you just recognize that
It's
it
really
is a
annoying they
perfect
made
square
it's really annoying they made the variable c in this one.
trinomial.
It's like not that c, the other c.
Yeah. Okay, so, but let's do it the way that they intended us to do it. So Hunter, are you ready?
Yeah.
Okay.
So we should start with the quadratic form for this equation will be -24 plus or minus 24, or the square root of 24 squared minus 4 times 16 times 9
Mhm.
over 2 times 16.
Good. Okay, so then that's going to give us -24 plus or minus. So you see what happens? We're going to get a square root of 0, right?
Okay. Mm-hmm.
And the square root of 0 is just 0. So that's why we wind up with just one real root. So we get, of course, the same thing that we would have gotten if we had done it by recognizing that it's perfect square trinomial. And then lastly, these on 147, remember if b squared minus 4ac is bigger than 0, there's 2 real roots. If it's equal to 0, there's going to be exactly 1 real root. And if it's less than 0 or negative, there's going to be no real roots, which means there will be 2 imaginary roots. So when my group did these for a, we wound up with the discriminant equaling 0. And so that means that there will be 1 real root. And for B, we wound up with the discriminant being -39. Since it's negative, that means there's no real roots, never crosses the x-axis, and there'll be 2 imaginary roots. And finally, for C, we got that the discriminant is 37, and that's a positive number. So that means that there's going to be 2 real roots. Since we have a couple minutes, I want to just real quickly pull up the graded part of the homework and just talk about it real quick because it's a little bit different. I mean, it's not too bad, but doesn't reflect this exactly. Let's see, 9.1, that's fine. Okay, so you can see that these practice problems, these are just plug and chug, solved by using the quadratic formula. Okay, so I guess I'm wrong. I must have dreamed what I told y'all. And then this is exactly kind of like the example problem that we did. The amount of junk mail received in 1 week by residents of a suburban town can be modeled by this quadratic function, where m of x is the pieces of junk mail and x is the number of years after 1980. So the x is the number of years after 1980. Assuming the model continues to hold, in what years are the number of pieces of junk mail expected to be 300,000? So how would you solve this problem? What would you do? What would be your first thing to do? And I can't write on the screen, so, well, I can, but what would y'all do first on this? Anyone?
Put it equal to 0.
Not set it equal to 0, but set it equal to, what's the number that they're giving us in the problem? Assuming the model continues.
3,000.
300,000, right? And then set it
300,000.
equal to 0, right? I think maybe that's what you meant. Yeah, so you're going to take, does everyone see why that is? You're going to take the equation. Let's see if I can get this going here again. Did not to mirror anymore. Whoops. Okay. Here we go. All right, so we're going to take this negative x squared plus 30x plus 100, and we want to know when the number of pieces of junk mail is expected to be 300,000. So we're going to set that negative x squared plus 30x plus 100 equal to 300,000. You don't put the thousands on there because the units are already in thousands. And then you're going to subtract 300 from both sides, and that will give you the quadratic function that you're wanting to solve. Now it says, in what years are the number of pieces of junk mail expected to be 300,000? So be careful, because what you're going to get two answers, right? One, if they're both positive, you're okay, because again, we're talking about the years since 1980, so you're not going backwards. So there's a possibility that you'll get two positive number answers, and that's fine. What you want to do with those numbers at the end of the problem is what do you think you need to do with those numbers? Let's say you got 5 and 7. I'm just throwing it out there. What year would your
That would be 1985 and 19.
Yes, right. You'll add that back to the 1980, right? So whatever you get, add that back to 1980, and that'll give you the years you're looking for. Okay, we're through. Any questions? If you do have any, feel free to hang on and I'll be glad to go over anything with you. Otherwise, y'all are free to go and I will try to get your tests graded by tomorrow.
All
Thank you.
Thank you.
Yeah, bye you guys. Have a great day. It's beautiful outside.
Hey, have a nice day.
Bye.